I'm Jake Ouellette. I'm a software engineer at Twitter. And this is my talk. It's called I Heard You Like Plugins. It's about architecting plugins for extensibility. So this is a talk about plugin development, but it's not really. What I want to do is I wanted to write a talk about extensibility and the Gradle ecosystem. And plugins are the architectural detail on how we extend Gradle. So ostensibly, I had to write a talk on plugin development. That said, this is a talk about good software engineering. So please feel free to learn broadly. So these are my perspectives. I've done a lot of Gradle development. Last year, I gave a similar talk to this, different content, but sort of similar high-level goals. And it motivated me to change a bunch of things in the Gradle plugin that I work on. So I think one of the goals that I'm getting out of this talk is to fix more things that I've busted. So I work on Fabric. Fabric is Twitter's mobile platform. It's a suite of mobile SDKs that developers can use to enhance their application. So one example of a Fabric SDK is Crashlytics. So Crashlytics is a mobile SDK for crashes as a service. And so there's this software as a service backend. You can go to a website, and when you ship your mobile app out to the Play Store or what have you, you can see these crashes on the website as your app builds up user lack of trust. So what is the Crashlytics plugin actually doing? So when a developer builds, they might have a method that's like foo. And this method gets obfuscated. It gets turned into like the letter A by a tool called ProGuard, which is used by Android developers. And we send up a mapping file to our backend that basically allows our backend service to map it back to foo. And we do this via a Gradle plugin. So this is a plugin that integrates with your builds and does a little bit of network I/O to send something to our backend. And this integrates on top of the Android plugin for Gradle. So this has sort of been where I was inspired for this talk. It's a talk about building plugins and being in an ecosystem where you're interacting with other plugins. So what are we going to talk about today? So one thing is I'm going to actually teach you about extensible software broadly. I'm going to contrast Gradle with some other tools out in the ecosystem. And I'm going to dive deep, and I'm going to focus on extensibility with Gradle plugin development. So let's pretend you're a software engineer for a moment. Let's say you're a senior Java developer. It's a mythical language. And you're creating a new build. So you apply plugin Java. I didn't want to single out any specific plugin developer here. So, and then let's hook it up to something that's a CI, and it also happens to translate builds. So you apply this plugin, CI 3PO. Great. Awesome. So then you hook it up to another plugin, and this plugin converts your resources into D3 visualizations in Java. So you apply this plugin, R2D3. So you've got all these cool plugins, and then you do a build, and you get an error. It says build failed. So now you're in a bit of a mess. You're stuck, and you have basically a kind of rough choice. Do you use R2D3 or do you use CI 3PO? Or you have a third choice, which is you pull apart these two messes of intertwined plugins into one individual one. So extensibility is a spectrum. You can make something super extensible, or you can build a walled garden. You can, make it so that it's actually hard for other developers to extend and build on top of your platform. I think for different plugins, it might make sense to do one or the other. But I think there are motivating reasons for extensibility. So it's really unextensible if CI 3PO doesn't work with any other plugins. It's more extensible if CI 3PO and other plugins are a feasible proposition. But it is the most extensible if CI 3PO's component pieces are in some way separable. Maybe not out of the box. Maybe if you apply the default CI 3PO, you get like everything that this plugin does. But it would be a really nice world if there's a hugely minimal effort in order to break them apart. So as a plugin developer, I'm actually not asking you just to make things extensible for me. I want you to be selfish. I want you to think about extensibility because it encourages high cohesion in your app. It makes it easy to extend your app with mocks. So if it's not super extensible, it's also not super testable. It's hard to replace real objects with fake ones. And it's easier to reuse elsewhere. So if you're building a plugin on top of the Gradle ecosystem, maybe you also need one for Maven or other build tools. If you think about extensibility, then it might be easier for you to reuse your build tools. And your code base is easier to understand because you've broken things up into logical component parts. So I sort of liken this to, and it's a little bit hard to see here, I'll get the slides up later, but the Star Wars trilogy has a lot of different characters within it, right? And they sort of like come together and then break apart. And so at face value, you might see this and you might say, well, that's actually a really complicated looking storyline. But I would argue to you that it's complicated because it has a lot of characters in it. Whereas if you take a movie, Primer, which Primer has only 3 characters in it, but because it's about time travel, it's very hard to understand what's going on. So my arguments are to make your plugin a little bit more like the Star Wars storyline than the Primer one. So extensibility in 2 steps. Step 1, build many layers. Step 2, each layer solves its own problems. So you'll notice here I'm not actually advocating for any specific solution. I'm not advocating for OSGI or Java 9 or like some J2E war-based solution or like Android services. Like there's a million different like modularity systems that exist in like the Java and Groovy and Gradle ecosystem that might be relevant even just to compare here. But to learn how to build extensible Gradle plugins, you must first learn how to program. So we could take a step back and we could say, hey, what do the advocates recommend? Well, Martin Fowler, classic software engineering 00 principles guy, came up with this solid term, which he says it's a set of principles, single responsibility, Liskov substitution principle, open for extension, closed for modification, interface segregation, dependency inversion. These are all like lots of different words that you can think about. But he's not the only advocate out there. It also turns out that unextensible code is unmockable. And so the Google testability team has come out with like a whole bunch of recommendations. They say, if you see these things in your code, there's something wrong, such as if your class does too much, or if you're reaching into collaborators, or if your class has singletons, or if constructors do real work. And if you go even deeper in the like classics of Java programming, Alan Holub, who was like big in the Java world, like Dr. Dobbs days of blogging about Java, he claims that extends is evil and that getters and setters are both evil. So, look out. So let's talk about good code. I want to give you some examples that show some of these principles that all these like buzzwords just gave out to you. And I'm actually going to argue that there's really just 2 core principles that you can draw away. You can sort of like blur your eyes and average these out. So let's say we have this R2D3 class and it has like a visualize method. And so maybe this visualize method takes some string, some project root, and then it gets some resources. And so it gets these resources out of a method that's inside the class. Now, the problem with that is that's a case of multiple responsibility. That get resources method is inside of this class, and it's impossible for me as another plugin developer to reuse the behavior of this plugin, but with a different implementation other than project root. So you might say, well, okay, what if I just extend the thing? I will make it not be inside this class. I'll make it be in part of another class. But I'm just going to extend that class. Well, that's the same problem. It's still unextensible even though you're now using inheritance. So it's still multiple responsibility. It's just through extends. So you try and keep coming up with new solutions to break this for me. And so you say, I'll just move it into the constructor. Now it's not a method. And I'll just like immediately call it. I'll call get resources on it. Great. So now it's still tightly coupled. It's a separate class, but you're doing new in a constructor in order to create this extra helper service. So this is still multiple responsibility, and it's now through constructor-based coupling. So I'm going to argue avoid new in constructors. Many of you have probably like experienced this and learned sort of like hardened lessons from trying to refactor other people's code. This term is called dependency injection or inversion of control. It's a really good practice to have. Okay, so then you pull new out of your constructor. You put it, instead you use singleton because that's a solution to having new in a constructor. Well, that's the same problem. It's now actually coupled to like the entire universe of the world of code because it's coupled to a global singleton. So it's still multiple responsibility, but now it's through singleton global coupling. Great. Okay. So now you move it out of the constructor and you do the new. You're still doing multiple responsibility. I'm just going to go past this. This is just another new. It's still coupled. You're not fixing it. So let's talk about good code. So in the good code world, you're just passing in, some syntax error there. You just pass in the list of files and then you set them. And so you have like basically an immutable field and then you use that later in your code. This might not actually like work for you in all circumstances. You might have to pass the list into the visualize method if like that state doesn't exist until that point in time. But it's now separated out. You now have to put that service like ahead of R2D3's like core functionality, which is to visualize. So that's single responsibility. That's one core solution. So let's talk about CI3PO, the translator. So CI3PO has a method that takes the task container object from Gradle, and then it gets by path the file finder, and then it gets the resources in here. So this is bad because it's tightly coupled inputs. So now if I can actually extend this, and I can extend this by basically constructing a fake version of like the task container. I could like extend it or something. And I could implement that method, and then the 40 other methods that task container have, maybe I wrap them, or I decide that whatever state they had if I'm extending a real object, that it's okay that they're like gross and weird and do strange things. But that's a lot of work, and it's fragile. So this is not ideal, whereas this is much simpler. If I'm just passing in exactly what this thing needs, then it's a beautiful implementation. So when we have this interface, get resources, one thing is that we might have like real implementations of it. We might have like a file finder object that does this resource discovery. So if you're passing in this file finder object here instead of the get resources, it's much more frustrating for me because just like with the task container, I now have to like create or extend file finder instead of just passing in an alternative implementation of that single interface that we had. So this is tight coupling through inputs having an overly specific implementation. All right. So what you might end up with is interfaces that have too many things in them. If a method doesn't actually need to delete or find, maybe that's an internal part of the resource service, then it doesn't make sense to actually pass it around to a million different objects. Basically bleeding scope that's irrelevant to services. So I would argue to follow you ain't gonna need it approach to software development by minimizing the contracts in which your objects are adhering to. And similarly, if you're passing in a resource service and you're doing like an instance of and then finding out it's a file finder, this is really bad because first of all, I might not realize you're doing this and I might think that I'm able to mock it. And then second of all, I have to now extend file finder again in order to get this piece of that code to actually run. And in fact, if you do a search of the Gradle code base, you actually will find 717 instances of references inside that code base. And I just want to say, instance of actually can make sense in a lot of cases. What I would argue is instance of only for immutable data types. So if you have like a service and you're doing instance of is this service or this service or this service, it's a code smell that you should just be asking that service to do the thing for you, right? Like if you need to know exactly what service it is, you're tightly coupled to that. Whereas if it's immutable data, it's not as much a problem. I would actually, like further reading if you're interested, like Scala case classes. And so I didn't dive too deep into the Gradle examples. Like those 717 instances might have been mutable data, but who knows. Continuing along here, what if CI3PO has an uploader sort of service that it's attached to? And when you pass in this resource service, you then reach into the uploader and you set a bunch of state on it. So you set its endpoint, and then you construct like HTTP client like request objects. So this is tight coupling through reaching into state. This is another form of just tight coupling. It would be much better if all you did was you asked the uploader if it already has these files instead. So you obfuscate away this like whole behavior of saying, hey, do you have this file? And here are the files. This problem can also flip over to the other side. So you can have a demand side problem. So you can have an interface that some service from some architecture is giving data to you and then not implementing all the methods on it, such as like throwing a new narrower there. And that's just as bad because then you have no idea what parts of the contract are actually going to be implemented, and you have to then do instance of to check and make sure you're not calling like the wrong methods on the wrong classes. So this is tight coupling, but it's through an extreme version of Liskov substitution. The subclass basically breaks everything. So we've gone through a bunch of examples, and I would break these down into two core principles. One, classes should have a single responsibility. Two, classes should not have visibility into scope they don't need. So just following these principles will give you a lot of insight into what is extensible about your code. So let's take a look at some existing build tools and just kind of like take them in context of Gradle and sort of the ecosystem. So let's talk about Ant, Maven, and Gradle. So Ant, as many of you probably used at one point in your past, is an XML-based build tool. You can specify dependencies that are just XML dependencies one task depends on another. And then inside these XML dependencies are all the specific state about what this task is going to do. What's a little bit weird about that is it's not always super clear what variables might exist, what properties or parameters can change the state or behavior of these tasks. So there's this thing that I would call like declarative spaghetti code that you end up with Ant because of like a mixing of concerns of like what your build is and of how your build works. I would caution against doing this within a build tool. Like this is equivalent to me of like checking like a global singleton. So you know that can make things hard to pull apart. So Ant also has no dependency management, although that's not actually true. It actually has decoupled dependency management. There's a tool called Ivy out there, which Gradle used to use for its own dependency management service, like under the hood. And Ivy is an XML-based tool that all it does is dependency management. It doesn't do any sort of like task graph construction. And in a sense, like decoupled equals reusable, which is a really nice thing. And so, for example, the Android Gradle support wasn't sufficient for our product's needs. We needed the ability to basically set up Android users with our SDK, and Gradle didn't work on Eclipse, at least to the degree that Android developers needed at the time. So we actually, and let me try and demo something here, who knows. Exit presentation mode. So we actually, what we do is we have a plugin for Eclipse that sets up your build with our crash reporting tool. And it's just like a little like IDE widget here that it sets up your manifest with our API key. It sets up your main activity with initialization code. And then we construct this file here that it looks like just like a dependency block in Gradle. It's just basically setting up our single SDK. And when I hit apply here, what actually happens is it downloads a jar file, an AAR file on Android from our backend Artifactory server. And let's hope hotel Wi-Fi is good. But it then blows it out into an Eclipse project on your desktop. And we did this because we needed a tool that could solve this problem. And there was this decoupled, like free-floating, like open source tool that actually solved this problem really effectively. And all we needed to do was have a fabric, not this property, just a properties file that defined what this dependency looked like. So that was a nice artifact of an extensible tool. Hold on a second. Okay. So we grabbed Ivy and demo. Okay. So then Maven, let's talk about Maven. And Maven tasks are tightly coupled to the Maven way. And I'm not sure if any of you have to deal with this frustration, but so for example, in Maven you have these lifecycle events like validate and compile, and you might have goals, which are like sort of, you can think of it as like subtasks. And so you can have multiple goals for a given plugin. And if I want to have my plugin actually run between two steps of your plugin, I can't. There's no way for me to say like run in between these two goals. They're actually in Maven, there is a Maven plugin that allows you to do this. It kind of hacks in the feature, but it's called the Maven Inherit plugin. And as I was saying earlier, like inheritance can lead to bad sort of coupling. So this, I can only extend the Android plugin once. So two different developers who are working on top of the Android ecosystem that needed this sort of capability wouldn't be able to do that feature. So that's coupling through inheritance. Another thing about Maven that's interesting is that there's configuration in the project that exists in XML. So the Android Maven plugin lets you rename your package name on Android. So you might want to do this, say, for example, if your app's like, comjkout app, and you have like a free version, and it's called comjkout app free. And so during your build, like you would rename it. And on Gradle, this would be like Groovy code that would be changing your build. And coming soon, it's going to be more like the Gradle model, which I think is going to be super awesome for this type of thing. On Maven, it's just XML. And so you might say like, oh, you can parse it, right? It's just XML, and that's awesome. But the answer is no, you can't parse it, because Maven actually supports variable resolution, which means that even though Maven is just XML, it's XML that has some statefulness to it. So plugins can actually get this state when they're running. They can like extract it by doing some like DOM parsing of the in-memory version of that XML file. But you can't get it if your tool is like a separate tool. Unless some open source project builds some tooling, but it's akin to spinning up the JVM, and it's a lot of work for a developer. So this kind of reminds me of in Gradle, the new plugin DSL, right? Like the new plugin DSL, if I wanted to like dynamically switch to being able to use like a snapshot object, currently with this DSL, it's not easy for me to do so, because I either have to pick to use this version or I have to pick to use this version. And so I can't just like say some version, variable thing like that. I think Adam mentioned that they're exploring like ways and better to support developers who have unique uses of these models. So I think at some point in the near future, like there will be really cool stuff you can do with this plugin DSL. But at the moment, if you need a parsable artifact that's like parsable by other tooling, I would say avoid Groovy code. And this is not down on like using Groovy code to make awesome plugins easy to use, but if you look at like Android or Java, like there are plenty of examples of having parts of like what your build is stored in properties files, stored in manifests, like manifest.mf for like Eclipse projects, Android manifest for Android projects. And like these are perfectly reasonable solutions to store some amount of the model of your project if you need it to be parsable by other sorts of IDE or tooling. And in fact, like if you think about it, like the dependency block almost is the thing that I need to be more static than the plugin block anyway, because a lot of like IDE tooling is built around the idea of like, hey, I'm going to make it easy for you to set up your dependency. In fact, I'll do a demo of that for us on Gradle. So I just showed you how we onboard with Fabric on Eclipse. So this is me just having the same thing, but we actually were parsing your Gradle build as best we can, and this is super heuristic. We're just like looking for closure blocks and like hoping that we're inserting code in the right place, but it ends up being super accurate and actually very effective. It turns out most developers have a very typical pattern, and when they don't, we basically throw an error, and the error is like very friendly and says, hey, you have to do this manually. So we are able to inject into your Gradle build, even though this is Groovy code running inside of build.gradle, there's like a lot of uniformness to these builds. A second. Good. Okay. So we can onboard Fabric and we can add like lines to your build.gradle, but like all these lines that you start adding to your build.gradle start building up. So let's talk about plugins and extensibility. So in your build.gradle, typically you have a little bit of declarative code. It's like descriptions of like what is in your build. And then you have a lot of imperative code. You'll have directions of how to do things in your build. And you might have like 1,000 lines of code in your build.gradle. Really, what you should have is one apply plugin in your build.gradle. This is the appropriate approach to describing imperative processes within the Gradle ecosystem. So a plugin will add for your build higher level models, which is really like a cleaner what is your build, and new tasks, which is really like how your build should actually be accomplished. So these models, there are plenty of examples of them. There's like the Android block, the Java block, Maven, OSGI. They all have a different syntax, and I think coming soon a lot of these will move into the new model component architecture. I didn't decide to talk about it much within this talk because I don't know sort of what the roadmap looks like for that enough to speak well to it. But I want to talk about like some best practices with these models if you're a plugin developer. So you're building on top of other plugins. Decouple the seams between your plugins and those other plugins. So I'll give you an example of that. On Android, there is this thing where Android developers, like in their default build.gradle, would have run progrard equals true. And so your build would be successful. And our plugin would actually read this, and then based on whether or not this was set, we would upload a mapping file to our backend. So your build successful, it would be true there. And then when Android Gradle came out with its 1.0 release, they had the Android run progrard, and they renamed it to Minify enabled. And so the ramification of that was new build.gradles had Minify enabled set up as the word in their script that references like whether or not progrard is actually going to run. And what they did was they backported it. So they made it so if you do run progrard equals true, it actually delegates to setting Minify enabled as a field, and your build would still be successful. But they did a funny thing. So they delegated the write access, but they didn't delegate the read access. So for all the customers using our tooling, suddenly their builds were broken with like the newer version of Android. And it was like only pretty much Crashlytics customers. There was like a Google Plus thread where people were like, yeah, I have Crashlytics too, no way, and that they figured out pretty quickly that it was our fault, or our fault. So this is necessarily like an unsolvable problem, right? Because you want your APIs to be flexible, to be able to change. You shouldn't feel like you have to lock into like downstream like plugins, like a crash reporting tool, locking you into having a certain model. You should be able to have like awesome models in your plugin. But if I am building on top of what the Android plugin is doing, I should do the best job to protect myself. And so what I would recommend to you is don't like check whether or not Minify enabled is set and then run progrard is set everywhere in your build. Do it once, store it in like some variable, and then what you want to do is you want to pass it forward. You want to pass like the representation of the behavior that you want your plugin to have forward. So this pass progrard enabled forward is really like pass should upload mapping files is enabled. And that's the correct state for the most part within your plugin. That's like the right level of your domain. And if you do something like that, then you can end up with the optionality to create your own model objects that represent these things. So you can like initialize them to null, and if they're not set, then don't do anything with them. But then if, say for example, Google breaks the API by changing it for run progrard, it's a pretty easy fix for your users until you're able to fix it yourself to just like override that property and have it be the alternative that they've now set it to. And I wouldn't be surprised if like new stuff in the component model would even make some of this process easier for developers. And currently in the current model, the way to do this is if you're writing a plugin, all you do is you do like project extensions create, and you name your extension, and then you pass in like a groovy pogo that represents this extension object that has these fields on it. And you can just like set them equal to null by default. So it's pretty easy. And you can add this like else if check here, and this is like essentially how you are getting that extra property added to your build script. So what about tasks? Well, so we had a very similar problem with tasks where There's this task within the Google plugin that is called the Dex task, and we depended on it in order to like figure out when to like upload our mapping files. We sort of like tried to inject ourselves at the right point in the build. And so for the Android plugin, this worked pretty well. You apply the Android plugin and we just do the right thing. But there are some users who use something called DexGuard. And DexGuard is kind of like ProGuard, except that with DexGuard, instead of mapping foo to A, it maps it to like a Chinese character. And then our backend can still map that Chinese character back into foo. And DexGuard has a bunch of other benefits. I mean, a bunch of security benefits to it with respect to like file compilation and preprocessing. But this DexGuard plugin, when you apply it with our plugin, it would actually cause a build failure. And the reason wasn't because DexGuard was doing something to the build that we couldn't support, except that they just had replaced the Dex task with something called the DexGuard tasks. They had like ripped out one task and replaced it with another. And so if you're in a circumstance like that, I have the same recommendation for you that I have for if you have fields that you depend on from other plugins. And what I mean by that is you want to like save the state of the thing that you care about once and then pass that forward as internal state. So the representation of what task should I bind to should be captured once in your build, and then you just reuse that thing later on. And you get the same optionality, which is pretty great, to say, hey, I can create an extension object here and set it to null. And then if any user wants to override it because they're not using the same exact looking Android plugin that I am using, they can still get the same functionality that my plugin is supporting. So they could set it to be DexGuard in that case, and it would fix it. So I wanted to give another example of weird coupling within a Gradle plugin. So the Java plugin has a jar task. And then there's this FatJar plugin that's open source on GitHub, and it has a task called the FatJar task. And in its documentation, it says this is the regular jar task. And like on maybe the next line, it says something that reads, "Note, regular jar and war tasks are not replaced by this plugin." So it took me a little bit of time to parse like the difference between these two. And so I looked at the code to try and understand. And what they meant is that they create a task of type jar, and then they override a bunch of default properties. But the task they create has a different name. It's called like the FatJar task by default. And they wire it up to your build when you apply it as a plugin. The problem with this is that now they've tightly coupled this implementation to the jar task. So they add some extra properties, but it has to be extra properties on top of the jar task. And so you can't compose it with any other jar task extensions. If any other plugin did the same thing, if you had like a FatJar and like an AwesomeJar plugin, they would not like layer together because they'd both be like separate pathways on top of jar. And so this is a problem. These other plugins would be trying to override the original jar task configuration maybe. Maybe they would say like, hey, the default jar task should have these extra configuration properties, and it wouldn't be captured inside of this FatJar. So solutions to that. One, you could allow the jar task to be injected. That's like an okay solution because then you can vary your behavior based on whatever the jar task that's injected is. Or you could separate your plugin's task out. So you could try not to replace other plugins' tasks with your own and instead just make smaller bits of behavior. So make a fatten task that just like handles class files and doesn't really care about like where they're going to end up ultimately with respect to like packaging. This might not be possible for the jar task in this instance because that might already be something jar is doing, but just want to call that out. Another thing about coupling is I try to avoid creating behavior inside of, say, for example, like do last blocks in like a plugin when they're getting applied. This is like a really bad testability thing because now you need like to integration test Gradle in order to test like maybe a pretty simple behavior like uploading a file to a backend. So I would say avoid that as much as possible. And one way you can avoid it is you can just make like a simple class or service that implements that single responsibility, and is separated out from your do last. Another probably more common way of solving it is you could make an upload task and just extend like default task, and you could add all of that behavior inside of there. I personally try and avoid this pattern because I'm working in a plugin that also has like Maven and Ant as compile targets, and also just like as a typical pattern, I feel really strongly that like this is extending default task, and even if default task in Gradle is not really doing anything special, that it's a breaking sort of single responsibility pattern, and it sort of impacts the ease of use of my system. So I pull this out into a separate service, even inside of like an upload task, and then I make that separate service just be like the sort of immutable pattern I showed earlier, where it takes all of its constructor parameters up front, it saves them as immutable objects, and then there's an upload method that just does that thing. And so these are really easy, really thin classes that you can then test. So the lesson there is avoid mutability. So one thing I was saying earlier was, hey, we map foo to A, or sorry, from A back to foo on our backend. And the way we do this is when you do a build, we put a UUID inside of your build. And this UUID maps like A back to foo. So then when you crash, it sends the crash up to our backend, and it has this UUID inside of the crash. And then we can basically figure out what this crash came from, like what version of your app or whatever. So therefore, we need an identifier inside of your app in order to be able to understand where your crashes are coming from. So this file looks something like this. It's just a simple XML file, and it has like an ID inside of it. And so our initial implementation of this was we generate a new ID when the build starts. We even were like a really bad actor. We generated the ID in the source folder, not the build folder. Don't recommend this. And so what would happen is we generate this ID, and the Android plugin would use it, and like everything would be awesome. But then a lot of our users started using like multiple different variants, which this is a thing that's currently like an Android model thing, and I think it'll probably be moving into more of like the general like component model of like different plugins. But it's really common for developers to have like different versions, like free and paid and debug and release, maybe combinations of those. So we would generate this ID, and then the free version would use this ID, and then the paid version would be using that same ID. And the problem is they would have different code, so they wouldn't actually map to the same crashes, and it would be wrong data in our system. So we came up with a new implementation. We said, all right, we'll generate the new ID when the variant build starts. So if you have multiple variants, we generate the ID, and then the free version would use the ID, and then we generate the ID, and then the paid version would use this ID. So this would be in like the merge resource step. It would like merge in this ID into the rest of the XML resources of the app. But then Gradle developers started using parallel build variants. So the Fabric plugin would generate an ID, and the Fabric plugin would then generate the second ID for like the paid version. And then the free version would use the second ID because it had already been generated, but it was the wrong ID to use. And the paid version would use that ID. And for the paid version, it was the correct ID. So users would get the wrong crashes. And what we wanted was, we didn't want to prevent parallelism. What we wanted was to be able to generate those two up front, and then they would correctly use each of their own. So the implementation solution was generate a variant-specific input. And I talked about this last year. I actually gave a talk about this. But the problem with my talk last year is I didn't actually tell you a solution. And that's because we hadn't implemented it yet. And so the solution to this, the solution we started with was we looked at the merge resources task in Android, and it has an input directory that it takes inside that task. And so we said, all right, we'll just put a file inside that task, and that file is going to have this resource. And it works great. There really aren't many problems with that, except Google doesn't recommend it because it's probably going to mess with like incremental compilation because they don't expect extra files to get input into this input directory. So it doesn't meet like their expectations for the contract. This sort of came out of a discussion with Zav in chat. So what we did instead was we tried to use the Android Models Dsl. So there's a DSL that they provide being a good player in the system and like supporting lots of users' different needs in their builds, they have something called res value, which is just on the variant object inside Android. And you can set res value. So I'm missing some syntax here. It should say like crashlytics build ID is equal to that, but that's okay. And so when you do a build, it would actually like generate this string file. But the problem is that this was missing this thing that we had originally been generating, this attribute in XML that said translatable equals false. So we tried this solution, and it caused lint failures for a bunch of our users. So that wasn't great. But fortunately, a newer version of the Android plugin came out, and it used something called the register res generating task. And so what this did is it let us say, hey, we have a folder, and use this folder for to pull in these res values into your merge resource step. And so the lesson to learn there is that your correct abstractions will facilitate users. Whereas if you get the abstraction, like if you try and make too many assumptions about what the user wants with their additions to your plugin's API, then there are edge cases that users will always run into. So it turns out that just like tasks being able to have more inputs is the relevant level of complexity that was needed for us. And there have been other plugins who have like dealt with the same issue and used this registration as well. So, and then, so finally, I'm running out of time, but I wanted to talk about one more thing that I've been working on. So a build's output is a function of what your project is, what you want, your local disk cache, the internet, tools, and then extensions to those tools. So like the output of your build is a function of a lot of things. Like we want it to be a pure function, right? Like we want like every task to always like behave the same every time it runs based on the inputs to it. But there's like a lot of things that can go wrong within a build. And finding builds can be hard. I don't know if you've ever had a curse of like up to date, whereby you have a task that just says up to date and you're not sure why, and you're like, hey, my plugin actually should have run this task this time, but it didn't, and I don't understand what's going on. And so then you do like assemble debug. And when you do that, you try and look at the build log and read it and understand what's going on, and you can't, because it's a really big, complicated file that has all the relevant information that you need, but it's unparsable. So I've been hacking on a Gradle plugin, and I open sourced it. It's on GitHub, and it's like in its really early stages. But it's called the Inspector plugin, and I'll give a quick demo of that. Find my mouse. So I actually have open, this is, and the screen's a little bit small resolution, but I'll zoom out. So this is a build, and so I'm just doing a D3 resolution, a D3 visualization of a build. And so on the left here, let's see if I can shrink text. Yeah, there we go. On the left here, we have all of the tasks that run linearly. And then on the right here, we have those tasks as they are connected to each other by depends on as a command. And so we can actually see all of these tasks. If I click one of them, I can see what changes it's made on disk. What I'm doing with this plugin is I'm not using the Gradle API for the actual production of like some of these things. So this is actually I'm like shelling out to the command line doing a diff on disk. And so I'm getting all these like diff files, and I'm basically generating a GitHub change looking thing. But then I'm saying for each of these files, is this change actually declared in your input or output? So this first section of this thing, which if I shrink text, yeah, it links in. So this first section of this thing is actually the input that was declared, or the output that was declared from this task. And then this is the specific file from that output directory, for example. And I think actually I can find that fabric task that I was talking about. So this is actually the fabric task, the Crashlytics build ID generation task that generates a build ID. And so I label tasks when they are basically mutating or like side affecting inputs. So that like if you haven't declared an output with your task, that you can then discover that and you can help out users who need incremental compilation. Now, our tasks, it needs to be generated every time, so it wouldn't really help them for incremental compilation anyway. But you can see here that this build ID is getting generated and that it's getting generated before the relevant tasks within your build. So you can, there's a sort of connection here, or at least there should be. Yeah, so this depends on this, which, yeah. That's the inspector plugin. It's open source on GitHub, so feel free to check that out. I'm super interested in sort of this idea of it being a little bit different from build receipts, in the sense that it's I want to give this to a developer who's using my plugin if they're running into issues using my plugin, and it will help me do a diagnostic procedure on that. I can discover things about the build that maybe introduce a little bit of overhead. So in conclusion, extensibility is good. Gradle's model is evolving, and it will have new facilities for extensibility in the near future. And there are lots of opportunities within the Gradle plugin community to have better designs. So I'm Jake Ouellette, and that was my talk.